Hi, it's snow day, and I'm sat at home doing differentiation because I lead such an exciting life. So, this is a really hard topic actually, finding dy over dx in terms of x. So I'm going to start off with an easier one of this hard topic, and it's really badly done, but it's trendy, I like it at the minute. So x equals sec y, find dy over dx in terms of x. So we're going to differentiate first, because it's to do with differentiation obviously. So dx over dy, we know goes to sec y tan y. Now I know though that sec y is just x. So dx over dy equals x tan y. Okay. Now what we can do at this stage is just flip it over, and we might work with the tan y later, but doing a flip as dx over dy, and that is 1 over dy over dx and vice versa, will get us another mark. So I think we'll be on about 3 marks now, okay? Now, the tan y is the one that's not in terms of x at the minute. So what I do is, at this stage, I always write an identity down. Now the only identity that links between sec and tan is tan's a sec c. So tan squared y plus 1 equals sec squared y. So, now we know that x is sec y though, and we want to find tan y in terms of x. So what I can write here, very cleverly, is tan squared y plus 1 is x squared, because x is sec y. So right now tan squared y is x squared minus 1, and now I make tan y the subject, so I want to replace it in a dy over dx. I get tan y is the square root of x squared minus 1. So that leaves me to go back and go dy over dx is 1 over x times the square root of x squared minus 1. And that's my answer. Now just to recap what I did, I differentiated dx over dy, I flipped, then I replaced any sec y's by x, and then I used an identity to get tan y, which was a remaining quantity in dy over dx that was causing the problems, and I made it the subject, got in terms of x, and ended up with a gradient of 1 over x, square root of x squared minus 1. So that'll be about 5 marks. Now let's go to a couple of more difficult ones. Now x equals 3 tan 2y. So I'm going to do the same again. Now this time dx over dy, tan goes to sec squared. So this is going to go to sec squared of 2y. But it's going to have a 6 in the front because you have to times by 2. So we've got 3 tan 2y going to 6 sec squared 2y. And what I do now is I flip to get 1 mark. So dy over dx is 1 over 6 sec squared 2y. Now I know now that nothing's in terms of x. Okay, so now I have to use identity again. But I've got 3 marks out of 5 already, so even if you do that, guys, that's alright. So what I'm going to write now is I'm going to write tan squared 2y plus 1 is sec squared 2y, because tan's a sec c. Now obviously I'm doing it in terms of 2y because everything that I need to have is in terms of 2y. Now I need to basically get sec squared 2y as a subject, so I can replace it in dy over dx. Luckily it's a subject in a minute, but I need to replace the tan squared 2y by something. So tan squared 2y is actually x over 3 for tan 2y squared plus 1, which is sec squared 2y. So I literally go and I replace dy over dx, and I go 1 over 6 bracket x over 3 squared plus 1. And that will be acceptable to leave, I think. But if you want me to, I will simplify that. So that goes to 6 x squared over 9 plus 1 on the bottom. Yeah, because that said, yeah, it was 6 times x over 3 squared plus 1, so it goes to 6 x squared over 9 plus 6. Now that means that on the bottom you can simplify it to be 1 over 2x squared over 3 plus 6, but the 6 goes to 18 thirds. So the bottom is 2x squared plus 18 over 3. So if you really wanted, you can write 3 over 2x squared plus 18, because if you do 1 over a fraction it flips. And that is the answer, guys. So I use the identities again after the differentiation and the flip. Okay, and I do 1 over 6 x over 3 squared plus 1, making sure that you times the whole thing by 6. Now, the last bit of simplification was just really showing off from me, but if it's a show that question, you will need to do it. If it's not a show that question, you don't need to do it. So, last but not least, a really tough one from a few years ago. It's an actual past exam question. It's x equals 4 sine 2y plus 6. So, start as I mean to go on, just differentiate. So dx of dy is basically 8 cos of 2y plus 6. Flip dy over dx is 1 over 8 cos of 2y plus 6. Now the cos 2y plus 6 is a problem at the minute. I've got 3 out of 5 though. So again, I've done my best. So fine, if you don't know how to carry on, go to other questions and come back. But now I need to have the same approach as before and link the identities. So sine squared of 2y plus 6 plus cos squared of 2y plus 6 equals 1. But I know that sine squared of 2y plus 6 is x over 4 squared, because sine of 2y plus 6 is x over 4 from the top. So you do x over 4 squared plus cos squared of 2y plus 6 is 1. Now the cos 2y plus 6 is what I want to get as a subject, because that's what I need to replace dy over dx to make it in terms of x. So you go cos squared of 2y plus 6 is 1, take away x over 4 squared. Now that is the same as 1 minus x squared over 16. Okay, which, if I'm being pedantic, is 16 over 16 minus x squared over 16, which is 16 minus x squared over 16. So cos squared of 2y plus 6 is this. Okay, so cos of 2y plus 6 is the square root of that. Okay, so dy over dx is 1 over 8 times that. Okay. And that's how I do it. Okay. So that's the answer.